Welcome to Module 2 of Multi-Agent Architect. If you've shipped a Claude Code session this week, you've probably built something cool. And then, like most of us, you've also stared at a folder of half-finished subagents that never quite did what you wanted. Here's the thing nobody warned you about. The reason most subagents fail in the wild has almost nothing to do with code. It's not the system prompt, it's not the tools, it's not the model. It's that the agent never gets called in the first place. An agent that doesn't trigger is invisible. It might as well not exist. In this module, we're going to fix that. We'll walk through the 4 contracts every production subagent has to honor. Frontmatter. Quick check on whether this module is the right room for you. Card 1. You use Claude Code daily. We're not talking about kicking the tires once a quarter. We mean your terminal is open right now, you've got a session humming in the background, and you've already burned through enough tokens to have opinions about model selection. Card 2. You haven't shipped a subagent yet. You've read about them. You've maybe forked one out of curiosity and read the YAML. But you've never sat down and authored one of your own from scratch, line by line, and put it into production. Card 3. You can feel single session ceilings. Your long refactors drift partway through. Your reviews quietly turn into rewrites. Here's the promise. 3 verbs. Build. By the end of this module, you will have a working subagent file written by hand. Not from a template. Not generated. Hand-authored, line by line, so you can debug every choice. Install. That file will be loaded by Claude Code. It will show up in the agent list. It will be discoverable both manually, when you call it, and automatically, when the orchestrator decides to route a task its way. Trigger. And here's where most tutorials stop and most people fail. The agent has to actually fire on the right tasks and stay quiet on the wrong ones. We'll prove it with a transcript, not a vibe check. All 3. Anything less is theater. You can have a beautifully written system prompt sitting in a folder doing nothing. You can have an installed agent that the router never picks. You can have an agent that fires constantly on tasks you didn't intend. None of those are shipping. All 3 together is shipping. Now the big idea of the module. Every production subagent is really 4 contracts stacked on top of each other. Contract 1 is the frontmatter, the shape of the agent, name, model, tools, the metadata that tells Claude Code what it is and how to handle it. A contract 2 is the description. This is the field that decides whether the router will call you at all. We're going to spend an entire lesson here because in practice this single field dominates every other failure mode you'll hit. Contract 3 is tools. What you're allowed to do. The blast radius. Read the file system, write to it, run a shell command, talk to an external system. Each one of those is a permission you're granting, and the convenience of granting all of them shows up later as a problem. Contract 4 is the system prompt itself. The brain. Identity, responsibilities, constraints, output format. We'll do them in order, because each one builds on the last. Frontmatter pins the shape. Description decides if you ever run. Tools decide what you can do once you do run. Prompt decides how well you do it. Part 1. The frontmatter contract. The 4 required fields, and what each one buys you. Here's a canonical frontmatter block for a code reviewer agent. 5 lines of YAML at the top of the file. Each line maps directly to one of the 4 contracts we just introduced. Name. How the router finds you. Stable kebab case, the same in code and in conversation. Description. Whether the router ever calls you at all. We come back to this in part 2 because it deserves its own lesson. Model. How smart, how fast, how expensive. There's a 50 times cost spread between Haiku and Opus, and you get to choose. Tools. Your blast radius. The list of things this agent is allowed to reach for. Omit it, and you inherit the parent's full toolset. List it explicitly, and you've practiced the principle of least privilege. Skip any one of these 4 fields, and you get one of 3 failure modes. The agent doesn't load at all. Or it loads but never gets called. Or it gets called and runs with the wrong cost profile, the wrong capability profile, or both. Treat the front matter like the contract it is, not like a config file you fill in by reflex. The first field is name, and there's exactly one rule. Use kebab case. Lowercase, hyphens between words. On the left, examples that work. Code reviewer, spec writer, log summarizer, security auditor. These names load cleanly across every operating system you'll deploy on. They show up correctly in the agent list. They round-trip through configuration files without anything getting mangled. On the right, the variants that look like they should work and don't. Code reviewer in Pascal case. Code reviewer with a space. Code_viewer with an underscore. And the special favorite of every team that ships agents in a hurry, code reviewer, v2, final. I know it sounds aesthetic. It isn't. The router uses your name as a discovery key, and discovery keys cross shells, file systems, configuration loaders, and command line interfaces. Each one of those handles spaces, underscores, and case differently. Kebab case is the lowest friction format that survives all of them. It's also how the user invokes you manually when they want to. Whatever you put here, they're going to type. Make it easy. Now we get to the big one.
Description.
I'm going to put a number on screen and tell you straight up that it's illustrative, not measured. The number is roughly 90%. Of the routing accuracy of your agent, roughly 90% is decided by what you write in this one field. Why? For reasons. First, other agents in the system see your description, not your code. The orchestrator never opens your file, never reads your system prompt, never inspects your tool list when it's making a routing decision. It reads the description and routes from there. Second, the orchestrator routes based on phrasing, not on intent. It sees the words you wrote, not the meaning you had in your head when you wrote them. Third, a weak description never gets called. A vague one fires on the wrong tasks. The mistakes look opposite, but the cause is the same. Fourth, and this is the one that hurts, your code can be perfect. Your system prompt can be brilliant. The tool selection can be exactly right. If the description is wrong, none of that matters because the agent never runs. That's why we dedicate an entire lesson, part 2, to this single field. That's the ratio. The last two frontmatter fields are the two control switches that decide what your agent costs and what it can do. Model. 3 tiers in the Anthropic family. Opus is for hard reasoning and novel problems where you need the full capability of the family. Sonnet is the workhorse default, broad capability, reasonable cost. Haiku is for narrow, well-scoped tasks. The cost spread between Haiku and Opus is roughly 50 times per token, which compounds fast in a multi-agent system. Tools. The blast radius. If you omit the tools field entirely, the subagent inherits its parent's full toolset, which sounds convenient and is almost always wrong. If you list the tools explicitly, you've practiced the principle of least privilege. A read-only subagent should never be granted edit, write, or mutating bash. Granting MCP tools is granting external access, different category, different risk profile. 2 switches. Move them deliberately. Both fields will get their own deep dive later in this module. For now, the headline is this. Your agent has a cost dial and a capability dial, and both default to risky if you don't touch them. Part 2. Descriptions that reliably trigger. This is where the rubber meets the road. A good description has 3 parts in this exact order. 1. Capability. What this agent can do in one tight clause. Plain language. Verb first. Not an agent that can sometimes help with code. Instead, reviews diffs for security and correctness. Active. Specific. 2. When to use. The trigger conditions. File types, keywords, phases of work, transitions between phases. This is where you tell the router what tasks belong to you. And the leverage move here, which we'll come to in 2 slides, is to add embedded examples that show the trigger in action. 3. When not to use. If you only do one thing in this lesson, do this. Embed examples in your description. On the left, the same description we've been talking about. Reviews diffs for security and correctness. That's it. The router gets one sentence to decide whether to call you. Triggers occasionally. False fires when someone says, check my spelling, because the word check is doing more work than it should. On the right, the same description plus one embedded example. The example is dirt simple. A user message, review my recent edit. An assistant response, dispatching to the reviewer. That's all the example needs. It's a tiny little anchor for the router. There's one phrase that when a description fails, it fails in one of two ways. They look opposite, but the fix is the same. Too narrow. Symptom, the agent never triggers. 3 patterns to watch for. The description names a single internal tool by version, something like reviews output of my internal tool v3 rc7, and no user is going to phrase their request that way. The trigger requires an exact phrase nobody types. The examples are too specific to your project, so the router can't generalize. Too broad. Symptom, the agent crossfires constantly. 3 patterns. The description says something like, handles all code-related tasks. There's no when not to use clause, so the agent has no idea what to refuse. The examples catch sibling tasks meant for other agents. 2 opposite-looking failure modes. 1 fix that handles both. Add a when not to use clause and add a concrete embedded example. The when not to use clause tightens the broad version. The embedded example anchors the narrow version to real-world phrasing. The deeper insight here. Too narrow isn't usually about being too specific. It's about being too specific to your machinery in language that no actual user would ever produce. Live rewrite. Same agent. 2 descriptions, side by side. On the left, the weak version. 3 words. Code review agent. That's all. No when to use.
No examples.
No negative space. The likely outcome? It fires on lint errors, because review pattern matches to anything code-shaped, and it stays silent on real bugs because the router doesn't know that's what it's for. On the right, the strong version. 6 lines. Capability. Reviews recent diffs for security and correctness. When to use. Use proactively after any non-trivial edit or write. When not to use. Do not use for spelling, formatting, or style. Plus 1 embedded example. A user saying, I just refactored. The assistant saying reviewing. Same agent. The system prompt, the tool list, the model, every other piece is identical. The only thing that changed is the words at the top of the file. And the routing accuracy is roughly tenfold. This is the lesson. The description is not a label. It's a contract with the orchestrator about when you run and when you don't. Spend 10 extra minutes on this one field and you'll save yourself 10 hours of debugging. Why isn't my agent firing later? Part 3. Tools. Principle of least privilege. The blast radius. Default state of a subagent file. Omit the tools field. Inherit the parent's full toolset. It's the path of least resistance, and it is almost always wrong. An agent with every tool is an agent that will, eventually, use the wrong one. 3 concrete consequences.
Drift.
A subagent that started life as a reader, only read and grep, eventually picks up edit and write because you didn't restrict it, and it starts mutating files when you didn't intend it to. You won't notice until something downstream breaks and you have no idea why your read-only reviewer rewrote a config.
Cost.
Tools aren't free to call. Bash invocations spawn processes. MCP tools hit external systems. Network calls have latency. An over-equipped agent reaches for tools it doesn't need just because they're available. The token bill goes up and the latency stretches.
Audit.
When something goes wrong, and it will, the blast radius of a failure is the union of every tool you didn't restrict. If you let an agent inherit everything, your incident report has to consider everything. If you whitelist 4 tools, you only have to consider 4. Treat the tools list like a permission screen on your phone. Approve each one explicitly. Be specific. Be paranoid. The convenience of all tools is paid for in 1,000 small ways. Here's the rule that simplifies tool selection.
Default to read-only.
Earn write access. The read-only set. 5 tools that nearly every subagent can have without much risk. Read for opening files. Glob for finding them by pattern. Grep for searching within them. Webfetch for pulling in external context, although this is the borderline case. And bash, but only the read-only commands like ls, cat, grep, head, tail. If your agent's job is to look at things and report back, this is your set. The earned set. For categories that should never appear in a tools list by default. Edit.
Write.
Bash with mutating commands like rm, git push, and pm install, anything that changes state on disk or in a remote system. And MCP tools, which can reach external systems, send messages, move money, post to Slack, file Jira tickets. Each one of these is a separate permission you're consciously granting. The cleanest version of this rule. If the agent's job is to look, it should never be able to touch. Pull a string out of a log. Read only. Refactor function. Earn the write access. Run tests. Read only bash with the test command pinned. Earn the more powerful tools by writing the agent in such a way that they're necessary for the job and the failure modes are bounded. For archetypes that cover almost every production subagent, pick the archetype before you write the tools field. The tools follow the role. Explore. Read. Grep. Glob. Webfetch. Investigates. Summarizes. Returns insight only. The pure reader can never accidentally mutate anything because mutation isn't on the menu. Builder. Read. Edit. Write. Bash. Mutates code. The agent that actually changes the file system. Always pair a builder with verification, a test run, a lint pass, something that catches the mistakes the builder will make. Reviewer. Read. Grep. Bash with read. Part 4. The system prompt. Identity, constraints, output. The brain. Every production system prompt has the same 4 sections. In this order, every time. The order matters, because each section flows from the one above it.
1.
Identity. Who this agent is. 1 paragraph. The character it inhabits when it answers. You are a security-focused code reviewer. Not you are an AI assistant that helps with code review tasks. That's vague identity, and vague identity produces vague output. The identity is the foundation, and every later constraint and decision flows from it.
2.
Responsibilities. What it must do. A short numbered list. Phrased as outcomes, not activities. Not review the code. Instead, produce a verdict of approve or changes required, plus a list of issues with file, line, and severity. 3. Constraints. What it must not do. Hard rules, expressed in bold language. We'll spend a slide on the difference between hard constraints and soft preferences in a moment.
4.
Output format. How it returns the result. A schema. Parsable. The parent agent reads the return, not the reasoning trace, so the return has to be readable by software, not just by humans. Identity, responsibilities, constraints, output. In that order. Identity comes first. Hard and soft constraints get different phrasings on purpose. If you mix the registers, the model collapses the difference and treats everything as a suggestion. Hard constraint phrasing. Capital letter must and must never. You must never delete a file without confirming. Refuse if the user asks for credential storage. If the input contains personally identifiable information, halt and report. Use these sparingly. Hard means hard. 5 hard constraints in a system prompt is a lot. 20 hard constraints in a system prompt is noise. The model picks 2 to enforce and waves at the rest. Soft preference phrasing. Prefer X over Y. When possible, return concise output. Favor explicit imports over wildcards. These are steering, not blocking. You can have many of these. They shape behavior without forbidding alternatives. The model treats them as taste, which is appropriate. The trap is mixing the two registers in the same paragraph. If you write, "You must prefer concise output," the model doesn't know whether you mean to refuse verbose output or just to lean toward terse phrasing. Pick a register per rule and commit. One more rule to live by here. If you find yourself writing 5 hard constraints back to back, you probably have 2 agents glued together. Split them. The output format section is the section that most prompts forget, and it's the one the parent agent cares about most. Here's what a good output contract looks like. A JSON-shaped return, a verdict field with a fixed enum, an issues array, each one with file, line, severity, and note. A summary capped at 280 characters. Why does it have to be this shaped? For reasons. The parent agent reads your return value, not your reasoning trace. Whatever happened inside your context is gone the moment you return. The parent only sees the return. Schema-shaped output is parsable. The parent agent can extract fields, sort by severity, route by verdict. Freeform output forces the parent to do its own NLP, which is wasteful and error-prone. A hard size limit on the summary is a contract, not a hint. If you say summary up to 280 characters, the model will respect that. If you say keep it short, the model will write you an essay. You can test the contract. Feed in a fixture. Assert the shape comes out the other end. Now you have a regression test for your subagent. If the parent can't parse you, you might as well not have run. The negative space technique. Tell the agent what not to do. Models default to helpful. Helpful is great until helpful means the agent wandered off and did adjacent work you didn't ask for. Helpful is what makes a code reviewer also fix the bug it found, and now your reviewer is a builder, and your tests are red because the fix introduced a regression. 2 flavors of negative space. Generic guardrails apply to almost any agent. Don't fix bugs you weren't asked to fix. Don't reformat unrelated files. Don't add new dependencies ever. Don't run destructive commands without confirmation. These are the universal rules, useful in basically every system prompt you'll write. Specific guardrails are where role drift gets prevented before it starts. Don't review style. The format handles that. Don't suggest tests when reviewing tests. Don't escalate severity beyond what the evidence supports. Don't return more than 5 issues per call. The specific ones come from observing your agent in the wild. The first time you watch your reviewer escalate missing semicolon to high-severity security issue, you know what guardrail to add. Negative space is where the boundaries between agents get drawn. Skip it and your specialists become generalists 6 weeks after you ship. Last section.
Part 5.
Model selection. When Haiku beats Opus and how to pick deliberately. The cost spread between Haiku and Opus is approximately 50 times per token.
Per token.
And it compounds. A multi-agent system with 20 workers, each calling Opus, racks up cost faster than you'd expect. A single orchestrator turned dispatching 10 Opus subagents is a different price tag from 10 Haiku subagents, even if all of them only run for 30 seconds each. The 3 tiers, treated as a budget, not just a quality dial. Opus. For hard reasoning, novel problems, and the kind of multi-step planning where you want every ounce of capability the family offers. Reach for it when the answer space is open. 3 families of tasks where Haiku closes the gap on Opus and sometimes outperforms it on cost-adjusted quality. Extraction. Pull the 5 issues from this lint log. Pull the dates from this email. Pull the test names from this report. Structure from noise. The answer space is constrained. You're either correctly identifying what's there or you're not. Haiku is fast, cheap, and reliable here. Classification. Is this ticket a bug, a feature request, or a question? 3 labels, 1 answer. Sentiment, severity, category. When the output is a small enum, Haiku is enough. Summarization. The pattern that ties this whole module together is called tiered orchestration. One expensive brain decides. Many cheap workers execute. The bill stays sane. In the middle, the Opus orchestrator. It has the hard job: decide which subagents to dispatch, integrate their results, decide whether to keep going or wrap up. This agent only runs once or twice per turn, but when it runs you want the full capability of the family. In the ring around it, the Haiku workers. A classifier that labels what's coming in. An extractor that pulls structured data out of unstructured sources. A summarizer that compresses what came back. A formatter that... Quick recap. By the end of this module, you can do 5 things you couldn't do an hour ago. Configure all 4 frontmatter fields with intent, not by reflex. Write descriptions that reliably trigger capability, when to use, when not to use, plus an embedded example. Pick the minimal tool set for each archetype, defaulting to read-only. Structure system prompts in 4 sections: identity, responsibilities, constraints, output. And choose Opus, Sonnet, or Haiku deliberately for each agent based on the answer space shape. The assignment for Module 2 is the same as the curriculum says. Build, install, and trigger 3 concrete actions. 3 time horizons. Pick the level you can commit to.
Today.
Open one of your Module 1 workflows. Sketch the 4 contract draft on a single page. Just the 4 contracts. Frontmatter, description, tools, system prompt. 30 minutes. Don't ship anything yet, just put the pieces in front of you, so you see the shape. This week. Ship the subagent file. Install it in Claude Code. Trigger it twice deliberately. Once on the task it's meant to handle, to confirm it fires. Once on a sibling task it should refuse, to confirm it stays quiet. Capture the transcripts. That's your assignment artifact. This month, pair the agent with a skill, a hook, and a / command. That's where Module 3 picks up. You'll start composing primitives into a small system, and the agent you built today becomes the heart of that system. Ship it. The build is the lesson. In Module 3, we go deeper into the orchestration primitives, skills, hooks / commands, and we start composing them.
See you there.